time to waste. Make a mark on my timeline. We're safe and sound. We come around. We are dancing the sundown. And we come alive. We're running out with strangers. 'Cause in the end we're all familiar faces. We young and wild, enjoy the ride. We made it. We made it. I don't need no sleep 'cause I'm already dreaming. Already dreaming. Say you'll never leave because I love the feeling. I love the feeling. upside down. Tell me where I'm going wrong. We don't have to be alone. I can see them brighter days. I can see the sun breaking through those clouds. Heaven knows we're all afraid, but we just keep holding on. I can see them brighter days. I can see the sun breaking through those clouds. Heaven knows we're all afraid, but we just keep holding on for the brighter days. But we just keep holding on for the brighter days. But we just keep holding on for the brighter days. It's a fine line between the light of day and the dead of night. I'm on the outside, looking for a reason to change my mind. Tell me where I'm going wrong. We don't have to be alone. I can see them brighter days. I can see the sun breaking through those clouds. Heaven knows we're all afraid, but we just keep holding on for the brighter days. But we just keep holding on for the brighter days. But we just keep holding on for the brighter days.
Ladies and gentlemen, good morning. Welcome to the 2019 COMPUTEX Forum on Artificial Intelligence. In today's forum, speakers from ARM, NVIDIA, Siemens, Micron, Alibaba Cloud Intelligence, and Google will share their insights on the layout and applications of AI for a smarter future. So, ladies and gentlemen, to kickstart the morning's program, let us invite Mr. James Huang, Chairman of Taiwan External Trade Development Council, TAITRA, to deliver his welcoming remarks. Please help me welcome Mr. James Huang.
Good morning, everyone. Welcome to AI Forum of COMPUTEX 2019. And I see the hall is full packed. And we can tell how attractive this forum is because we have gathered some of the best minds in the industry to share with us their visions and insights for this very important technology. And yesterday in COMPUTEX opening ceremony, I mentioned that new technologies, like a huge digital tsunami, has forever changed our economic landscape. And we are entering into an era where everything is linked, connected, and constantly learning from each other, man, machines, things. And in this new digital landscape, every company, every industry, in order to survive and thrive, every industry has to be a digital industry. And every company, no matter what field you are in, whether you are in ICT, you are in agriculture, you are in medical, you are in manufacturing, finance, every company has to be a tech company. And new technologies like 5G and AI will unleash life-changing powers and change our societies and economies. And in particular, the convergence of new technologies like 5G, AI, IoT, and big data will reinforce each other and create an effect that I call a digital Big Bang. And I think we are on the verge of a digital Big Bang in human history. And COMPUTEX is actually the best window to see this new world. So if you want to see how the AI will shape our future lives, there's no better chance than this morning's section. And I want to share with you that last week I was in Japan, visiting some of the leading companies in Japan. And one of them is a company hidden in the forest under Fuji Mountain. That company is the pride of Japan. And when I went into the factories, I saw no people there, all machines and robots. And it's a shocking thing for me, because when you walk into an automation factory, all you hear sounds like babies crying and laughing. So it looks as if you are not in a factory, you are in a nursery schools. You know, when robots are working, all you hear is the sound of electric motor, and it sounds like babies are crying. So I asked myself, perhaps this is the future of human life. You never know. And some people say AI is the last invention of mankind. I certainly hope not. And it sounds like the scenario of Hollywood movie, Terminator. But I think we are more optimistic about human technology and our power to control this technology. And AI is certainly one of the most important technologies that will shape the future of our life and the destiny of mankind. And I think we are embarking on a very exciting digital journey of mankind. And there's no doubt that AI will play one of the most important roles in our future. So this morning, we have invited 6 distinguished speakers from the most renowned companies, from ARM, Siemens, NVIDIA, Micron, Alibaba Cloud Intelligence, and Google. I'm sure you will all enjoy this morning's section, and we all look forward to a wonderful sharing from our distinguished speakers. Thank you.
Thank you, Chairman Huang. Chairman Huang, please remain on the stage for group photo shooting. We would like to ask Chairman Huang and all the speakers for the morning session to please go on stage for group photo shooting. Ladies and gentlemen, please help me welcome Renee Haas, President, IP Products Group, ARM, Mark Hamilton, VP of Solutions, Architecture and Engineering, NVIDIA, Erdo Elver, President and Chief Executive Officer of Siemens Limited Taiwan, Thomas T. Eby, Senior Vice President and General Manager, Compute and Networking Business Unit Micron, Sean Dean, Chief Scientist of AIoT, Alibaba Cloud Intelligence. Ladies and gentlemen, let us have a warm round of applause to welcome our speakers for the morning session. Coming from ARM, NVIDIA, Siemens Taiwan, Micron, and Alibaba Cloud Intelligence. So all the speakers and Chairman Huang, please put up your thumb for the photographers to take a couple of more photos. Thank you very much for joining us in the morning. Thank you, Chairman Huang, and thank you, And our sincere thanks go to all the speakers for the morning session. Please return to your seat. And with that, we conclude the group photo shooting session. And we will now proceed to the keynote session. Today's first keynote speaker will be Rene Haas, President of ARM's Intellectual Property Group, IPG, and a member of the ARM Executive Committee. He took over management of IPG in 2017 and is responsible for all IPG activities, including product development, engineering, sales, marketing, and commercial operations. Without further ado, please help me welcome Rene Haas.
Ni hao. Good morning, everybody. Thank you for that introduction. I don't know how to think that I'm responsible for all of ARM's IP products and sales and marketing. That sounds a little ominous. But as mentioned, I work for ARM. We're the world's leading provider of semiconductor intellectual property and based in the UK. I am thrilled to be here this morning to talk about artificial intelligence and its impact on our world going forward. It is indeed, I think, as James said earlier, an unprecedented time relative to our industry and the impacts that are going to take place relative to all things around AI. It's very, very significant in terms of when you think about just the intelligence that's coming into machines and the intelligence that's going into everyday lives. And when we think about it inside ARM, we work with all of the partners inside the ecosystem. We work with a great number of partners here in Taiwan and across the globe. And we see examples of this every day relative to what's going on. A very small example maybe to start with today is just a simple example of AI taking place at the edge, right? What takes place in our smartphones today. Very simple example is around augmented reality, if you will. So we're here in Taipei, and our smartphones have the ability to capture an image. And with that, the smartphone has an ability to not only capture that image, but very quickly give you a number of facts and pieces of information about the image that you captured. So here we're looking at Taipei 101. And by just taking a picture of Taipei 101, there is enough intelligence inside the device to recognize exactly what that building is. It can recognize that building was started construction in 1999, and it took 5 years to build, and it cost about $2 billion US to build. And for about 6 years, it was the tallest building in the world. So, those who traveled in the past will remember that there was no cell phone, there was a big guidebook, there was a camera, there was a bunch of things that you needed to carry around to give you this kind of feedback relative to what was now in your fingertips, which is really, we take this for granted today, but this was not very long ago in terms of what these devices could do inside the smartphone. And this is AI that's taking place inside a smartphone that has a CPU. I'll talk a little bit more later about the intelligence inside. But this is really, a bit of the tip of the iceberg about what people will want to do with their devices. So one of the use cases that we hear a lot about when we talk to partners is to take the experience to a whole nother level, right? How do you create an experience where the information you're capturing on your smartphone can now actually talk about a scene or an image relative to a live video stream, right? So let's say, for example, I want to create a scenario where I'm going to now look like I'm actually doing a live feed of a video, real time, behind Taipei 101. So one of the things you have to do is you have to capture the data. And then there is a fair bit of work that has to take place inside the smartphone to align the audio data and the video data, right? So let's say, for example, I want to catch sounds on the street. I want to catch noises from vendors. I want to make a scene very, very real. I want to be able to align all the video information that's coming in with the audio information to create a backdrop. and then take that and overlay, you can recognize who that person is, behind a screen that actually then makes it look like I'm doing a live feed inside of Taipei 101. Now, this capability is not there yet today. There's just not enough throughput and horsepower inside of the smartphone to make this happen, but this is going to happen, right? And this is a very, very simple use case of where AI is going to be making predictions about the background, predictions about the audio, predictions about the video, doing a number of overlays, and with that is going to be able to handle a high degree of artificial intelligence. Now today, when we think about artificial intelligence and what is the current state of the art, if you will, what is the capability of AI that sits inside today's smartphone? So roughly speaking, there's about 4 billion smartphones in the wild, what we would call the installed base. And virtually all of those smartphones today are doing some level of AI or machine learning or getting smarter. The example I showed earlier about Taipei 101. And today, a lot of that computation, and our folks did some research around that, about 85% of that computational intelligence around machine learning AI takes place in either a CPU or a GPU, the classic technology that exists, inside smartphones today. So what this tells us is that machine learning is happening today. It tells us that AI exists inside these machines. It tells us that the workloads are largely addressed by the current technology. But when we look forward, and our teams did some work in terms of talking to developers about what is the platform, or said differently, what is the underlying hardware that developers will need to use for future AI solutions. So this survey is somewhat interesting. It points forward the fact that increasingly the needs of developers have to be addressed by hardware that is heterogeneous in nature. That means that the underlying hardware is not just a CPU, it's not just a GPU, it's not just an NPU for machine learning. It's a series of dedicated pieces of hardware. And with that, developers will then need to think about exactly how they write their software, how they write their code, what the solution needs to look like on the underlying platform. And these are the themes that, when we think about them inside of ARM, we talk about a notion around total compute. And that's taking all of the underlying processing elements to deliver solutions. As I mentioned before, ARM, our business is around licensing semiconductor intellectual property. We develop this underlying hardware, we provide it to silicon people who make chips. Those chips go into end products, and those end products can do everything relative to all the things we talked about with AI, ML, et cetera. And because these underlying compute elements are very general purpose in nature, they can then be tuned for almost any end vertical market. And I started with an example of the smartphone, and I'm sure you'll hear this from some of our other speakers this morning. This type of machine learning and artificial intelligence is going to find its way into every single end market that we engage in. Every market is going to have needs for artificial intelligence, is going to have needs for machine learning. And one of the things that we see going forward is that we are just at the very beginning in terms of where we are relative to compute needs. James talked about a big bang moment in terms of what's taking place inside the industry. I could not agree more. I think what we're seeing across all of these industries are significant compute challenges in terms of performance, in terms of efficiency, in terms of raw compute power. Now, one immediate example is autonomous driving, right? So today, there are a lot of cars that are being introduced. I think there was an Audi 2018 A8 that has a significant level of driver assist and ADAS capability. And it has machine learning running at a rate that, if we think going forward what the needs look like, we think that the level 5 needs of the car going forward relative to the Audi is maybe 300 times more computing power. And then when you think about 300 times more computing power, and you think about an automobile that has to be very efficient in terms of power, efficient in terms of overall performance, that is a lot of challenge that's put on the computing industry. Additionally, just the raw lines of software code that go into an autonomous car are beyond what you see in today's aircraft. So you can look at the numbers there in terms of the lines of code. These cars of the future are going to be incredibly complex, and the needs in terms of compute requirements are going to be very significant. Now we see the same thing in terms of in servers. The explosion of 5G is going to mean a much higher degree of data that's going to be going through the cloud, a much higher degree of data that's going to be connected at the edge, and with that, a tremendous increase in capacity that's going to exist inside the data center. And that's not just the data center sitting in a large cloud, but that data center is going to start to move from the cloud to the edge. Now, there will still obviously be large data centers that are going to be doing high levels of compute, but just simply the raw amount of data that's going to be required to be processed, the AI components added upon that, the storage is going to mean a high degree of compute. We're also going to see much more machine learning taking place in the cloud and at these edge servers. And again, working in tandem with the edge devices. So the problem statement that we see in terms of compute challenges with autonomous driving, very, very applicable to edge servers. Same story really with wearables, right? The next generation of VR headsets and augmented reality are going to be a step function, big step function from what we see today. So today's devices are a very amazing experience. If you've ever had a chance to play with a VR headset, I would recommend you have your meal after you play with a VR headset than before. It can be extremely immersive. But the capabilities for not only for things like gaming, but industrial applications, medical applications, there's just a huge number of areas where we think VR can take off. However, today's VR headsets are heavy. They have very, very poor battery life. They're not very, very efficient. And going forward, the compute challenges required to make these VR headsets a great experience are going to require a much higher degree of compute capability. And then when you start to incorporate all the things around artificial intelligence, it adds more and more taxing features onto the platform. And then, of course, smartphones. Our belief is that this market is going to continue to grow in terms of compute capabilities. The devices will become more intelligent. When we just think about the efficiency that's required and the performance increases, you can see the numbers there going forward. The significant challenges around these devices are going to be very, very high relative to the compute capabilities. We think that the smartphone of the future is going to require potentially 60x more performance than what we see today. And that, if you look backwards in terms of what's been added, just going back to that example I talked about in the beginning, about all of the frame rates, there are big challenges going forward. Now, one of the challenges that exists across all of these sectors, autonomous, edge servers, wearables, smartphone, is security. Now, we have to think about, as an industry, what are the right solutions in terms of security, what's going to make the data private, what's going to ensure that these devices cannot be hacked, what's going to make sure these devices are going to be able to be safe in terms of how they're used. This is a huge, huge industry problem that everyone needs to contribute and solve. And when we think about the challenges, they're not just only around security. There's some other very significant challenges in front of us. You know, there's silicon process. Silicon process has evolved quite a bit over the centuries, or excuse me, over the years that we've been involved in this industry, but it's starting to slow down. At the same time, the compute requirements are going up. So we have this conundrum of process reaching a limit, at the same time needing to add more performance. We also have issues with the processors potentially being domain-specific and areas that are specific to compute elements. How do we mix and match these areas? And a very, very important area is around developers. So today, the CPUs that are programmed are done in a certain method and language. Things are potentially a little bit different when you're programming a GPU. When you add a neural net processor, and then more importantly, you start to address developers in different communities who have been very accustomed to developing software on a certain platform, there's a lot of challenges relative to exactly how programmers can bring this to market. So while we believe that there are significant opportunities in terms of what AI is going to bring, we definitely see challenges in the industry in terms of how to address all these issues relative to making the devices faster and more efficient, yet underneath the hood, you've got all these computing elements that are different. How can we make it easier for developers? That's a big question. So as I mentioned before, the business that we're in is around developing products that go into semiconductor products that go into end devices. So some examples here of some of the things that we build are CPUs, GPUs, machine learning, etc., NPUs that are very dedicated. And as I mentioned before, largely today, they go into SoCs that are purpose-built for a certain end market. They may not be specific in terms of addressing the markets that need artificial intelligence and need ML, but at the same time, we know that the end market wants solutions around that. So what we see taking place with these solutions relative to these end markets is now our end users starting to take the combinations of these to address the areas I showed earlier. So when I talked about autonomous, and I talked about autonomous driving, we're now starting to see partners building SoCs that incorporate these elements to address a very specific problem. So at ARM, one of the CPUs we've developed that's very specific for automotive is a device that provides what's called dual-core split lock. And in layman's terms, that basically is redundancy in the system that should one CPU fail, another CPU can take over. Not unlike fault-tolerant systems inside an aircraft. When you think about safety and you think about everything that's involved in safety relative to an autonomous car, it's paramount that you address this. So we are starting to see in the autonomous world a total compute solution. And when I mentioned before about the level of complexity required from that today's Audi to the car in the future, when you think about the amount of performance that's required, we just can't throw more cycles at the CPU. It's just not going to be able to keep up. There's going to need to be a level of co-processing that takes place in the automobile. The GPU is going to have to do some level of work, and there will definitely be dedicated machine learning processors. Now, when we think about the edge, we start to see some of the same thing take place. Earlier last year, and then towards the back half with product announcements, we introduced at ARM our Neoverse line of CPUs, and these are very, very high-end CPUs that are dedicated for the infrastructure market. And what we see in this market is partners building SoCs that combine lots of CPU cores, 8 cores, 32 cores, 64 cores, maybe even larger. We see a combination of that with machine learning. We see a combination of partners building this. Again, there's no way to address this burgeoning growth in terms of AI and ML without a dedicated total compute solution. Same scenario exists in wearables. In wearables, you have a very, very power-constrained environment. You need extremely long battery life. You need CPUs that can run on different processes to have an extremely long battery life. We see the same period and same pattern also existing. People who want to combine the ML, GPU, and CPU performance. And we also see the same thing in smartphones. Again, we see the combination of these products. Now, one thing that we see that is extremely consistent across the partner base, and these are, again, our partners who build SoCs for these end markets, is the need to have a common software framework. Because the software required to build these devices is extremely complex. There is a tremendous amount of overhead that's required. The developer community, if I've learned nothing else in my 30-plus years in this industry, wants tools that are easy, wants development platforms that they can get access to in a straightforward way, doesn't want to have to learn how to reprogram things, wants to really, at the end of the day, not really know what the underlying hardware is, doesn't really know it in terms of the ISA or what needs to take place relative to the underlying processing element. It just needs to be easy. So we have to solve this issue. We have to solve this issue relative to making the frameworks very, very easy to use. I'll talk about it in a minute where we think we've made really good progress in this space, and I think this is something that uniquely positions ARM relative to the industry in terms of this overall solution. Having a software framework that's very easy for developers to access to is really important. And then there's security. As I talked about earlier, this is as big a problem that we have to solve around AI and ML and SoCs going forward. It is a very, very key area. We introduced a technology, I think a couple of years ago, maybe a year and a half ago, called PSA, which stood for Platform Security Architecture. And with this, we worked with our partners across the industry to essentially define a set of criteria around specifications, around underlying IP, around encryption, that would ensure that partners who were building devices, that if we could comply to this underlying architecture, and then along with a certification test, could verify and validate to the end user that the device was security compliant. And we've had huge adoption of this. We've had silicon partners get behind it. We've had a number of OEMs get behind it. And again, security is really paramount for this world going forward. The total compute area is just not going to stick. We're not going to have any kind of growth and traction if we can't address this. Go back, maybe it was a year ago at CES with Spectre and Meltdown. I think people remember those creepy code words. It really highlighted a couple of things for us as an industry. One, that these problems are extremely real and they can happen at a moment's notice. Secondly, it also taught us that the industry has to come together and work on these problems jointly. And I think if there was one positive that came out of that whole Spectre and Meltdown mess of a year and a half ago, was that it really highlighted the fact that as an industry, the industry really came together and worked towards common solutions and platforms around the fixes. PSA is very similar, right? So PSA is really about this compliance test. It's around security that will just work out of the box, and we've started to see a lot of great adoption with it. Now, I just want to spend a few more minutes here talking about developers and what's so important. So by our estimate, there's 23 million people on the planet who call themselves software developers. Now, this can be people who work inside the companies that are presenting today. These could be people working in the garage. This could be a hacker working at home. There is a giant developer community, And this developer community wants to be able to address, program devices in a very, very straightforward way. So we've been thinking about this problem a lot. As I mentioned before, when we think about total compute, it's really beyond just the CPU now. It's about all of the underlying hardware. So at ARM, we have put a lot of emphasis around frameworks that will make it very straightforward for the developers to use the products and code that they know and not worry about what the underlying hardware is. So we have a framework called ARMNN, which helps partners redirect code from what they develop at the top level to the underlying hardware. They can use their favorite languages, whether it's Caffe or TensorFlow. We've done a lot of work with compute libraries. These are libraries that will allow the underlying hardware to work with the software in a very straightforward fashion for things like face recognition, as an example, where we could upload profiles that could be used by the programmer. And then a lot of work around the development area. Things like ARM Mobile Studio, which is about allowing developers to model their systems, and a number of areas in that space. This is an area that we're very, very focused on. We think it's extremely important in terms of enabling developers to be able to port the systems going forward. Everything I talked about earlier relative to the growth of AI and the growth of ML, this is as big a problem that has to be solved as any. Because if you go back to the notion that silicon process is indeed slowing down, yet the computational requirements are going up, this means that people are going to need to develop platforms using different hardware than they've used in the past, and this really only works if the development platform is in place. So it's a big focus area for us, and we've made a lot of good progress here. So, in summary, where do we see AI, and where do we see things going? I've been coming to Computex for the last 15 years. And the show has really evolved a lot relative to seeing a tablet that was a little bit smaller or a PCI card that was a little bit lighter to now look at the kind of things we're talking about. We're talking about artificial intelligence, machine learning, robots, smarter than humans. The impact of what is in front of us right now is as significant a sea changes as we've ever seen. And when we think about AI from our company standpoint, we really think about the notion of total compute. That's heterogeneous computing. It's around really having efficiency of a software ecosystem, and then something that really addresses all markets. Because again, this is not just about smartphones, it's not just about a wearable, it's about every industry that we touch. And I think that's what makes this as an exciting a time as ever. I can't wait to see what the next number of years look like. I think even over the next few years, we're going to see a set of products and solutions that we haven't seen before. And I think it's going to be great to be on the ride. With that, thank you for your attention, and have a great COMPUTEX.
Thank you, Mr. Haas, for joining us this morning. And the next speaker will be Mark Hamilton, Vice President of Solutions Architecture and Engineering at NVIDIA. Mark is responsible for working with customers and partners to deliver the world's best end-to-end solutions for AI and deep learning, professional visualization, and high-performance computing. Today, he will talk about how AI can improve healthcare. So, ladies and gentlemen, please help me welcome Mark Hamilton.
Good morning, everyone. I'm glad they did not keep that life-sized or super life-sized picture of my face up for too long. So today I'm going to talk about healthcare. It's great following ARM. NVIDIA has been, of course, a great partner of ARM. We like to say that we work with all of the great CPUs out there, but we, of course, incorporate ARM into many of our products, from our Drive PX platform for automotive. And most recently, what we announced just earlier this week is our new EGX Edge server platform. What many people don't know, maybe, is that the NVIDIA Deep Learning Accelerator, one of the cores of our Tegra GPU, has actually been adopted by ARM through ARM's Project Trillium. So we work very closely in both ways with them. But just getting right into to healthcare and, in fact, AI in general. As Renee talked about, AI is fueling and touching every industry, right? And so much of COMPUTEX has a focus, of course, on AI and IoT. And healthcare is one of those important ones. Every company doesn't work in every industry, but every company has employees, and those employees have family members, and they all need health care. So again, often I think everyone loves the work that they do, whatever industry it's in, but the work that we do in healthcare touches all of us. I thought I'd start a little bit just by quickly reviewing NVIDIA's platform for accelerated computing. NVIDIA, of course, started 26 years ago with PC gaming and computer graphics. And of course, COMPUTEX still spends a lot of time talking about PC graphics. And we had some great announcements earlier this week in that space with our new NVIDIA Studio line of workstations and laptops. Of course, CUDA now has expanded to over 200 different APIs. I was backstage listening to Renee talking about the programming environment and being able to develop new AI applications. And of course, we don't want to do that all from scratch. We want to be able to have a very rich and robust programming environment. And that's what CUDA-X and all of our other different frameworks and platforms provides. Now, I thought it'd be interesting to talk about the impact of AI, not only in healthcare, but worldwide. By a number of industry estimates, it's estimated that it's about $16 trillion would be added to GDP over the next few years. Now, to put that in perspective, assuming that GDP growth was evenly spread across every person in the planet, that would be about $8,000 US to the GDP of every person in Taiwan. So think about that. If you live in Taiwan and you go home tonight and you tell your friends or your spouse or your family members, you say, because of AI, everyone in our family will have $8,000 more US to spend in several years. That's a huge potential impact. Now, of course, that impact may not be spread evenly, but I think as I'll talk about, there's no reason that AI cannot be adopted by any country in the world, and that any country in the world can't benefit from it. And I'll talk about some of the reasons why. When you think about AI, it really is several different things going on. Of course, an AI has to sense the world around it. That sensing can come often from IoT sensors. It can come from big data that's been stored in a database for a lot of time. You then need to reason about that data, right? With the explosion of IoT, there's been an explosion of data. And just think about advanced medical imaging, right? Not only X-rays, MRI machines, ultrasounds, handheld ultrasounds, genome sequencing devices, flooding more and more data to the world. The challenge is, of course, transforming that data into knowledge as early as possible, right? And that's why the growth of edge computing and AI at the edge. Of course, AI will happen in your data center, but it's impossible to take all of that sensor data, video or otherwise, from your cell phone or other device and bring it all back to the data center and do the processing there. So again, AI will increasingly be pushed out to the edge. And of course, manufacturing robots aren't new, but new AI-based robotics is maybe one of the hardest things to do, because even an autonomous car, a self-driving car, which has not been mastered, no matter what some auto companies say, we're still some years away from that. The job of an autonomous car is not to run into humans or other objects. A job of a robot, a modern robot, is actually to interact with other objects, pick things up, bring them to you, put them in a drawer. So again, robotics is a very, very difficult challenge. And of course, robotics interacting with healthcare will be one of the uses of robotics. But let's step back a little bit and think about, what does it take to build AI code? And in fact, this is one of the core reasons why I like to say that AI is really democratizing software development. If you think back to 10 years ago in software development that was done then, and think about who are the leaders in software development. You either had countries that had how many software developers, how many engineering students did you graduate, right? China and India graduate about 1 million computer scientists or 1 million engineers every year. Very, very hard to compete with 1 million engineers at graduating every year if you're writing if-then-else code. But AI is different, right? AI isn't developed by an engineer writing if-then-else code. AI is developed by an engineer taking data, inputting that data into a computer model, a deep neural network or other AI model, and then generating a new AI program out of that. And so this is why what you need for AI is you no longer need 1 million developers, or think about it as a company. Some very big companies used to say, well, I have I am a world leader in software development because I have 50,000 software developers, or I have 10,000 software developers. At NVIDIA, relatively small company by some IT standards, we have about 7,000 software developers. And today, we don't count how many lines of code those software developers, right? We count how many deep neural networks they develop. And so, of course, to develop that code, if data is the new source code, then what you need to write the source code is world-class infrastructure, right? Again, the inferencing, the processing, the running of that computer program, once it's developed, will be sometimes in the data center, sometimes out on the edge. And again, a great reason, going back to that development, of having our deep learning accelerator not just embedded in our GPUs, because our smallest GPU, the Jetson Nano, $99, about 5 watts. There are certainly many ARM devices or other devices that are going to fit in a much lower price point and a much lower power point and don't need even the Jetson Nano power. But again, writing the equivalent of a deep learning accelerator, right, there's about probably 100 companies today that are doing so-called AI chips, right? Some of them large AI chips, some of them, you know, small as our deep learning accelerator, which will be being incorporated into the ARM platform. Well, the question is, how do you program it, right? And so again, having access to those hundreds of different CUDA APIs, having access to the million-plus CUDA developers all over the world to program not just a GPU, but program any device with the NVIDIA Deep Learning Accelerator hardware incorporated into it. But let's jump into healthcare, talk a little bit about some of the areas where NVIDIA is working in healthcare. We tend to focus on 2 different areas of healthcare. One is medical imaging. Medical imaging in the past used to be done by traditional computer vision type programming, writing if-then-else code to recognize features. Today, more and more of that, over 70% of medical imaging research today is done using AI. In fact, yesterday, I had the pleasure of meeting with Chinese Medical University in their hospital, and they're using the NVIDIA DGX2 to train deep neural networks, doing things like testing bone density. It's very common in Taiwan and elsewhere in the world when a young child goes in for an exam, they'll take an X-ray of the hand, and the way it was previously done is a doctor would have their atlas, literally a book of hand X-rays, and they would go through and flip and study and say, make sure, is the child's bone density, are they developing age appropriate? And if not, then we need to do further tests. That would take about 2 to 3 minutes for a typical well-trained expert in bone density to do. If you're just maybe a family physician, it might take 10 minutes or more of looking through this atlas, paper images, and comparing it against the X-ray. Using the hospital's new AI, they can do this in literally an instant. That's 10 minutes of time the doctor can spend more with the patient, or 10 minutes of time that they can spend with other patients. So again, huge advances in medical imaging and huge opportunities there. Again, I think that there are so many startups in this space. NVIDIA alone is working with over 250 startups in the medical imaging space. And I think the challenge, and one of the things that NVIDIA is doing, is really bringing those startups to the rest of the ecosystem. Think about it. If you're a large hospital somewhere in the world, you're not going to go, and no matter how good the startup's AI is, you're not likely to go to a startup, buy a Dell or HP or Lenovo workstation to run their software and put it next to the MRI machine, right? You're buying that MRI machine from Siemens or from GE or from Philips, and you're going to buy the software that provides that they buy. So how does NVIDIA help bring together the startups, the existing medical equipment providers, and then create an environment where, in fact, the medical equipment devices that have a 10-year lifespan typically can go through and be upgraded or can take advantage of all the work, the AI work that's being done. The numbers are rather astounding. Not counting X-ray, but looking only at advanced imaging, MRI, PET scan, CAT scan, ultrasound, there's about 300,000 advanced imaging devices sold every year. And they have a 10-year lifespan. So there's about 10 million of them out in the field. And so that means, but they're almost never upgraded, right? Because they have to have FDA approval. So think about that challenge and say, well, how does a MRI machine, state-of-the-art $5 or $10 million MRI machine that GE sells someone today, how does that take advantage next month or next year or 5 years down the road of some new AI software that's being developed? So hold that thought for a minute, and we'll go through. But again, if you think about and say data is the new source code, then medical imaging devices of all types are the perfect data sources. Right? The numbers are just staggering of the types of data that is coming out, from small, even handheld now genome sequencers that can go out in the field, to large multi-million-dollar advanced imaging devices like cryo-EM machines. AI is being applied across all of these. But it's a very complex world, right? It's not just trying to recognize a pedestrian or a bicycle or a stop sign. You have many different modalities, types of images, right? An MRI image is very different from an ultrasound image, and you need to understand the different types of images. There's a shortage of radiologists. Even in the US, where we spend probably more in the world than almost anywhere else on healthcare, there's 50,000 radiologists for roughly 300 million people. And there's a shortage in the US of radiologists. I looked up some numbers just out of interest. In Taiwan, the average annual spend on healthcare is about $2,500. So there's two ways to think about AI and AI's impact on healthcare. One is if AI can not only do better AI, better healthcare. Remember, think of that spending a fraction of a second to determine bone density of a 5-year-old's hand X-ray versus 10 minutes. That's going to lower the cost. The other way to look at it, and again, I'm not the expert in how much should be spent on healthcare, but if per capita income increases $8,000 per person, can some of that be spent on better healthcare, right, or on more healthcare? So again, great opportunities from both the cost driver as well as the availability of funding that AI can bring together. And so, of course, you say, well, NVIDIA, you're a GPU company, right? Are you getting into the medical imaging business? And of course, the answer is not. We're going to be very focused on driving the underlying tools and infrastructure. And we take all of the tools and infrastructure that we're developing with many of the leading hospitals around the world, with the leading medical equipment providers, and we put that together in what we call the Clara AI Toolkit. Now, a lot of people say, well, what, Clara, that's a little bit of a funny name. Where did Clara come from? Well, of course, NVIDIA is a US company, and Clara Burton was the founder of the American Red Cross. And so that's where we came up and had our inspiration for the Clara AI Toolkit. A number of different features in the toolkit, and it's tools that we provide to startups, to hospitals, to radiologists and experts to build up medical imaging and other types of applications. So let's walk through a few examples of those tools. When you take an X-ray, or you take any sort of image, of course, the first thing that it's read by a radiologist, right? And so that radiologist is sitting in a back room or sitting across the country or sometimes in a different country, right? Gets the image, and they go through and they read it, and then they make notes in your electronic healthcare record. And so, of course, with Clara, it doesn't automate the entire process, but it goes through, and here's an example where a radiologist is using the Clara toolkit for AI-assisted annotation. He or she is going and highlighting some portion of the image, and then the AI is recognizing and identifying what's in that image. It's perhaps highlighting it in 3D, filling in and coloring the organ, or the item that's being x-rayed. And then the radiologist can go right side by side. Again, this tool, Clara, has then been used and integrated into the electronic healthcare system. So the radiologist, using their existing workstation, their existing workflow, can annotate it. Now you say, well, how does this address the problem of that 2-year-old or 5-year-old or 1-month-old MRI machine that's shipped with maybe an older GPU or older software? Well, the entire Clara toolkit process doesn't sit inside the MRI machine. It's sitting in the hospital data center or in your national healthcare private cloud. And of course, medical images, they don't live only in the MRI machine, right? Anyone who's ever been to the doctor's office, you see, well, the doctor pulls up the MRI machine from a server sitting in the hospital network. Well, just like the doctor can pull it up and display it on the screen, you could pull that into a toolkit or to a tool that's been built on top of Clara AI. Transfer learning, another feature. This one is a little bit complicated to explain, but basically the way to think about transfer learning is if you want to develop a new model, right, for recognizing a new type of disease or a new type of cancer, the AI expert doesn't have to start from scratch. They start with one of the existing models that's been placed in Clara, in the Clara toolkit, and then they reprocess some additional images with that and create a new model. So rather than going through and requiring 10 or 20 hours of compute time on an 8 GPU DGX, they can go through and just in a matter of a few minutes retrain the model with additional data. So the transfer learning toolkit in Clara enables AI specialists in the medical field to speed up developing new models. Finally, our AI deployment toolkit. Again, this is a set of tools that the AI developer, once they go through and build a new model, they can then go through and deploy it out into the hospital systems just with a very simple drag and drop of the network. And you think about it, and you think through all of the things that are required to do here. It's very different than traditional software development, right? Anyone who's ever written software knows you use a source code control system, right? And you have all of your source files that go into the program. You collect all of those source files and you compile them into a program, and then you ship that program out to your customer. Well, AI is very different, right? Your source code is your data. It's the AI models, one or more that you use to develop them, and many different versions of all of those. So in effect, the old tools of managing source code don't work in the new world of AI. New types of tools, such as the AI deployment toolkit in Clara, help you do this. So again, a number of different features in Clara and a number of different universities around the world, all leading hospital systems that have adopted Clara. National healthcare system in Europe, the American College of Radiologists, which all 50,000 radiologists in the US are in, and a number of other different universities. Ohio State University, one of the leading medical universities in the US. King's College in the UK is one of the key colleges in medical universities that develops software and systems for the national healthcare system in the UK. The UK is one of those countries that has been in the news lately, but unfortunately not for healthcare, but they have a national healthcare system. So again, anyone that goes through the national healthcare system in the UK will now have all of their medical imaging analyzed by a system based on NVIDIA's Clara toolkit. American College of Radiology, again in the US, making Clara and the Clara tools available to all 50,000 radiologists. Again, as a toolkit, and it will also have models and systems and will continue to improve over time as more and more hospitals, more and more medical equipment providers build up on the knowledge base. Now, for those that think that AI-based imaging is just, well, it's startups, it's not real, it's still in the future, we think it's not. And in fact, last year, Siemens, one of the largest medical imaging companies in the world, started shipping the first production-based AI-based toolkit with their tool that's described here. Now, of course, besides medical imaging, drug discovery, right? Pharmaceutical companies around the world spend billions and billions of dollars to develop new drugs. And this is a process that can take years, sometimes decades. And so applying AI to the drug discovery process promises to shorten the process and speed development of new drugs. And in the US, there's a consortium, or it's actually worldwide. It's the US Department of Energy, which does research in all sorts of areas, Britain's GlaxoSmithKline, one of the largest pharmaceutical companies, and the US National Cancer Institute have all combined to use the Clara toolkit through this consortium for drug discovery. And finally, also out of the UK, it's amazing when you have a national healthcare system that you have a lot of national funding for AI and other initiatives. But Oxford Nanopore is a company out of the UK, and they develop genome sequencers. They have two different types of sequencers. They have sort of your typical full-size tabletop type of system, very high throughput, generates many terabytes a day of data, as well as a small portable system. That small portable system has all sorts of uses. And of course, genome sequencing isn't only used in healthcare, but for instance, one of the big uses of the Oxford Nanopore portable sequencer is throughout Asia and India, being able to go out into the field and sequence the genome of crops and go through and study crops and diseases out in the field. So very proud to have Oxford Nanopore using NVIDIA GPUs. And again, in the smaller portable one is our Jetson GPU based on an ARM core. So again, stepping back up in a little bit to a higher level and saying, what can NVIDIA do not only with healthcare, but in other AI initiatives and help countries adopt it quickly? Well, we have a whole partnership that we think about for collaboration at the national level. This includes a number of different things. Of course, it includes the NVIDIA hardware and NVIDIA software technology. It includes education through the NVIDIA Deep Learning Institute. So last year, NVIDIA trained over 100,000 people, 100,000 developers in AI in the NVIDIA Deep Learning Institute. We have now over 40 different courses. And again, these are not to teach the theory of AI. The theory of AI is taught very well in universities, but these are very specific courses taught to use to develop AI-based software for a particular type of application. AI for medical imaging, AI for financial services, AI for building a drone or for building a self-driving car. So again, a lot of different things going on. And again, just a reminder of Taiwan's leadership in the AI space. We're very proud to have been partnered with Taiwan since 2017 through a number of different initiatives here in the country. So thank you very much, and hopefully it's a pleasure being here, and hopefully you enjoy the rest of the show. Thank you.
And thank you, Mr. Hamilton, for joining us this morning. And the next speaker will be Erdal Elver, President and Chief Executive Officer of Siemens Taiwan and Vice Chairman of European Chamber of Commerce, Taiwan. Prior to these roles, he worked as President and CEO of Siemens Vietnam and General Manager Jiangsu Province and Vice President of Siemens China, just to name a few. Today, he will talk about co-creating a digital future with Siemens Industrial AI. Without further ado, I will now turn the program over to Mr. Erdal Elver.
Good morning, ladies and gentlemen. 大家好. Good to be here, and thank you for the organizer for giving me the chance to speak in this great conference. I am representing Siemens. This is the leading German technology company in digital solutions and industrial artificial intelligence. So I will talk about technologies and also share with you some real cases where we have applied our industrial AI solutions and our IoT platform MindSphere. In my speech, I will focus on 3 topics. The first one will be, today AI is common in many daily applications and has huge future potential. And industrial AI is, in fact, AI technologies combined with domain knowledge, like automation, electrification. So that's the first. Second one, with industrial AI, we, as Siemens, are shaping the future in key economies, like in infrastructure, in industry, and energy systems. And I will share with you a couple of real examples of what we are doing in this sector. And the third one, for developing AI applications in industrial field, you will need powerful IoT platforms. And in that section, I will introduce you our MindSphere, which is our IoT operating system to develop AI applications. So with this in mind, let's start, and let's come to the first one, AI. This is a term which, well, raises hopes, but also provokes concerns. Computers who can recognize images, who can understand the spoken language, natural language, do, well, illness diagnosis, as we have heard in previous speech, and also beat grand chess masters. And today, one of, let's say, major applications in AI is in natural language. And in most of smartphones, we have this application already. And there have been a very impressive live demo in one of the Google's developer conference. I guess there are people from Google? Okay, sorry, I take some example from your company, because one of my boys is working for your company. The other one is working for Siemens, by the way. And there was a live example where it was a live call was done to a hair salon. And the lady on the other side didn't know that she was called by a machine. So Also, computers are using words what usually humans being are using, like or okay la. I have another example I will share with you and see, what happens.
El Cocotero, how may I help you?
Hi, I'm the Google Assistant calling to make a reservation for a client. This automated call will be recorded. Can I book a table for Tuesday the 12th?
Okay, cool. And how big is the party?
It's for 2 people.
Great. And when did you say they want to come in?
Tuesday at 7 p.m.
Okay, let me check. I don't have 7, but we can do 8.
Yeah, 8 p.m. is fine.
Perfect. And can I get their name?
First name is Anna.
Okay. We'll see Anna Tuesday. Thank you.
Okay, awesome. Thanks a lot.
So, you see, machines can nearly speak as good as, human beings. And today, around 1 billion people are using those technologies. In nearly, as I said, all smartphones, we have those things. I have studied computer science in the 80s and was also dealing with natural language processing. And I remember we needed, huge computers to recognize one sentence. And you needed to, train the machines to understand your voice. This is all today much better, of course, due to the further development in technologies. And we are able to gather, analyze big data. We have huge computing power, even in the smartphones, which we are utilizing. And of course, also we have today much better algorithms than during my university time, because we are developing things much better today. So that is the development of artificial intelligence. And there is a studies from McKinsey saying AI and applications in AI in different fields will add around 1.2% value add over the next years onto the GDP. It's a huge amount. And will add around 13 trillion to global economy, global value added by around 2030. So that is a huge potential of AI. And with this, of course, we will have new sorts of functions. And also this report says 375 million people will learn new profession by 2030. So that means we are moving from, let's say, labor-focused work to skilled work. And this is something which is changing our world. So this is really amazing. And Siemens has recognized this potential and working already more than 30 years on this topic. As I said, I was hired at Siemens around 30 years ago because I was dealing with artificial intelligence, and at that time, especially working on development of so-called expert systems or knowledge-based systems. So AI experts might know what I'm saying. So we have worked in different fields and developed, of course, applications in industrial sectors, and we do believe, besides the, let's say, consumer applications I have just shared with you, artificial intelligence in industrial applications will create in future additional growth, economic growth in different industries like infrastructure in buildings and transformation, mobility, in industry, optimizing the manufacturing processes, but also in energy systems. So that is what we are talking about, industrial artificial intelligence and the potentials in industrial sector utilizing the AI algorithms, again, to run things better and more efficient and also solve problems what we were not able to solve in the past. Once again, industrial AI, we mean utilizing artificial intelligence techniques like neural networks, deep learning, machine learning, recognition of patterns, and also, again, was a good example from the NVIDIA friend talking about applications in healthcare sector, which is an important area. And those will, again, give us new ways of solving problems and optimizing things. So that is what we say, where we say huge potential for us. And we are, in fact, working already quite long in different technologies, again, to provide what we call a digital future. There are around 14 core technologies where we are working at Siemens already over many years. And you see a couple of them here, like additive manufacturing, where you need to print, for example, components of turbines with 3D printing, autonomous robotics, blockchain applications, and so on. But most importantly, data analytics and artificial intelligence. So that is an area where we are working already quite long. We have, in fact, already invested, now coming my next slide, more than 30 years invested development in neural networks and similar technologies for innovative solutions. We have invested a bunch of money, around 500 million, on trainings each year, and having more than 800 experts today. Of course, this number is growing. We have established AI labs in different regions of the world. We have it in Munich, we have it in US, we have it in China. And of course, here we are aligning our developments with our business units, working for different sectors, like, as I said, in infrastructure, for like buildings, transportation, for industry, manufacturing, but also for energy sector. So, of course, important, once again, data analytics and artificial intelligence for industrial applications. So that was the first part. Now I'd like to share with you a couple of real cases which we are using artificial intelligence techniques to do things much better. The one is in manufacturing. Again, manufacturing complex products requires also complex manufacturing processes. And there are different steps which can be optimized. One of the steps is the quality testing, where you can use in conventional way X-ray machines to identify faults of products and others. Or the other way is you can equip the production process with the service algorithms, which can gather the relevant data by the manufacturing process. Then you can utilize AI algorithms to do better and accurate prediction of the quality of your products, for example. With this, our colleagues, for example, helped to reduce around 30% cost in quality testing. Another example is, again, from the manufacturing sector, where we can utilize the digital twin with AI techniques. Digital twin is the software model of a machine representing the different status of machines. And this can be a product twin, this can be a production twin, but also we are talking about so-called performance twin. Take, for example, motors, as in this case. Motors in manufacturing play an important role. You have tens of motors running continuously, and optimizing their operation and reducing the cost is, in fact, one of the key topics in manufacturing. Here, we can combine the data from the digital twin with the sensor data and obtain new parameters which you usually cannot obtain with normal sensors, like, for example, torque, in German, Drehmoment. So that is an information you can get utilizing a digital twin and the sensors, which gives you a better information about the condition and situation in a running motor. With this, you can simulate the performance of the motor and run AI algorithms to predict the performance and the condition of the motor. And with this, you can take decisions, do maintenance, for example, before a motor breaks. So this can help you, of course, to do preventive maintenance and help you to, of course, avoid downturn times. So that is another application from the industrial sector. The next one, data centers. In fact, in the digital age, data centers plays a huge role. In fact, the servers are not in the white cloud of the God, but somewhere in the data centers of Google, Amazon, Alibaba, Apple. And according to the analysis, by 2025, data centers will account 1/5 of the energy consumptions worldwide. And this is a huge amount which we have to consider. So that is one aspect. We have to know the cooling, air conditioning of data centers is one of the area where the energy is mostly consumed. So that is something where we have to look at. And another one is, also according to the statistics, there are a lot of redundancies, which is important. But most of those redundancies are too much. So Siemens, together with Vigilant, developed a system, an AI-based thermal optimization system, utilizing the deep learning neural networks, analyzing, let's say, the consumption and autonomously managing the airflow and optimizing the air conditioning system. And with this, reducing up to, let's say, 40% energy consumption. So that is an example, again, in data centers where we can optimize the energy consumption with neural networks, deep learning, and industrial AI. Another example from transportation. This is someone from Turkey? No, this is a picture from Turkey. There's a high-speed train of Siemens running between Istanbul and Ankara. And today we can equip the high-speed trains, especially the core components like wheels, brakes, with sensors, which can continuously get the data of the train and upload to the cloud, where the service people can analyze and also predict, for example, future failures of the brakes or wheels, which can again help the experts to do preventive maintenance. So another area of artificial intelligence where we can help to do better prediction of the performance of the train. So it's another great examples from infrastructure. Energy systems, I have mentioned a couple of times. We can utilize AI algorithms to optimize the combustion process. If a gas turbine running, it is burning gas and turning and with this, of course, generating energy. And this process can be optimized with AI algorithms. And our experts have already developed systems which is today in use, which can help to reduce the CO2 or NOx emissions. And this is one of the key topics by energy generation, as you might know, reducing the CO2 emissions. And also increase the maintenance intervals. Again, the same as before. We can, with this, predict the future performance of the turbines, and also with this we can do predictive maintenance, and with this they can optimize the usage of the gas turbines, which is crucial in the energy sectors, as some experts might know. So that is another great example where we can utilize AI techniques, also again, deep learning neural networks, to optimize the performance of the turbines. Stay in the energy sector. Offshore wind turbines. Taiwan is about to build new offshore wind farms, and I think Taiwanese are aware of this topic. Usually offshore wind turbines are set somewhere in the sea, and you cannot go each time and repair if something happens. Those are equipped with sensors, which, of course, continuously getting the data, and the wind turbines can analyze the patterns from different components, from the blades, from the generators, and also measure the wind speed, wind direction, and optimize its performance. This is the one aspect. Another aspect, this data can be sent to the service team, which is sitting somewhere on land, and they can remotely identify failures or issues, and with this, solve the problems in 80% of cases, even in 10 minutes. Again, which helps to run the wind farm in a more efficient way, and you don't need to send someone to the high sea and do the things. So it's another great example. Well, has been mentioned in the previous session, we are developing high-tech MRI scanners and CT devices. And also here, our experts have developed algorithms, AI algorithms, which can help to recognize patterns in the images. And with this, doctors can do better diagnosis by support of again, AI techniques and image recognition, pattern recognition algorithms. So another area. My last example from building technologies. In fact, we are spending most of our times in buildings. Also here, we have developed applications where we can, for example, identify user locations or provide information to the facility managers to optimize the space allocations on one hand, but also we can learn from behavior of users, how much cooling or how much heating or how much lighting someone needs, and via the AI algorithms, I can provide solutions which can be done automatically through the building management system. So this is another area where we are using AI techniques. So those are applications from different sectors where we are using industrial AI to run things much better. As I said in the beginning, for powerful AI applications, we need also powerful platform which can help us to develop the AI applications. And as we are talking today about cloud applications and solutions, cloud-based solutions, we need also a powerful IoT platform which can help us to develop the AI applications. For this purpose, Siemens has developed MindSphere, which we call an IoT platform, which help us to develop AI applications. I will give you a bit insights on this in the following. So it is our, again, open IoT platform for applications, industrial applications. We have the physical devices, motors, I have just mentioned, turbines, trains, and you name it, and they are somewhere. Now we want to develop applications which are on our phones or on our computers, and this can be somewhere. Now, to connect the physical devices with the applications, I need a platform in the middle, ideally a cloud-based IoT platform, and that is our MindSphere, which connects the physical devices with the applications. And again, applications can be different type of applications, predictive maintenance, recognizing different patterns. Again, utilizing the interfaces to the platform, from the MindSphere platform to the devices, using the connectivity algorithms, what we call MindConnect. So that is MindSphere, what we are now utilizing to develop not only general applications, but especially industrial AI applications. Of course, development of applications needs different parties. And here is another great example where we are helping to create a kind of platform, a partner ecosystem. And our system is based on different available platforms, and those are, for example, Amazon, from Microsoft Azure, and since recently based on Alibaba. There will be a speech from Alibaba after, I think, my speech, of course, to develop applications in Chinese environments. So that is our platform. We have, in fact, established so-called MindSphere application centers in different locations. Application centers for different applications, for city applications and others. And most importantly, we have also established one here in Taiwan, in Taichung, for the machine tool industry. I have an example. Let's watch what we can do with MindSphere.
盛源公司在1972年成立，现在已成为一家世界级的四面包制造商。本公司所生产的是木器的四面包木机，不论是在前段、中段、后段，都需要它来做成制品。我们目前已经制定一个标杆，不论是在设定机械方面，机械里面也有智慧的元素，这是我们公司引以为傲的。 我们要持续这样的产品优势，维系我们的竞争力，让我们对卓越的要求随时能与客户结合，不仅仅在产品的交货当下、授权受众之后，都能够收集大数据、交换使用心得。这就是我们为所选择了Siemens的 MindSphere 的服务。
透过 MindSphere 的帮助，我们的产品能够轻易地连接实际生产的数位讯息。 让收集取得的资料转换成关键的资讯， 协助我们从设计、生产、工程规划到服务，优化整个价值链，回馈在我们的客户身上。Siemens 将生产设备、使用者、制造商连接在一起，意味着我们能够缩短应变时间，拥有更多的弹性可能，并能让产品更符合客户的期待，具备更佳的资源分配，达到高效节能。而这一切只需透过 Mind App， 任何时间地点轻松取得资料。MindSphere 不仅提供了完整的数位化服务，也能够根据我们的需求制定应用程式。无论将来产品在全球任何地方，我们都能借由 MindSphere 随时随地准备好我们的协助与建议，提供客户最佳的方案。
这是一个追求卓越的过程，也是一门结合传统与科技的生意。面对越来越多变且更复杂的市场 ，MindSphere 提供了一个符合成本效益、虚拟化资料的管理系统，而这正是未来的产品趋势，左右企业成败，带来竞争优势的利器。
All right. So, this is an example where we can utilize MindSphere and, again, AI applications to solve certain problems. Another application, and I have also a short clip to show, is here used in city applications for air quality monitoring in Hong Kong for a smart environment. You see a picture, some devices which are gathering the data from different locations. And just let's look the clip, and I will try to explain during the clip is running. So you see here the collection of data, the color shows the different types of data, like CO2 or ozone or different values. And now continue. And with this, I can watch what levels of the air pollution is existing. Then I can also change to looking different time period. This was the daily, and this is now about several days. I can change certain parameters, but also I can look, for example, the locations where the data is collected, and I also see through the colors the air quality in different areas of the city, and I can also look into the details of the parameters. And with this, I have possibility to monitor the air quality in the city and also take actions if something happening like air pollution through traffic congestions and you name it. So different features have been shown here in the system. And yeah, that is another application of MindSphere data collection utilizing AI algorithms to recognize different patterns. An important element here is the building a kind of, as I said, partner ecosystem, a platform where different companies developing software solutions, OEMs, end users, EPCs can be connected. So that is what we call MindSphere World. And the next MindSphere World Conference will be here in Taiwan. So if you are working in the sector, welcome to scan this picture, and then you get more information about the conference of MindSphere World, again, where we are bringing different parties together and letting them to share information. Before closing, I have a short clip to summarize what I just talked about it. So I hope you get the picture.
Siemens, ingenuity for life.
All right, this was a short summary of the major topics I have just mentioned. Before closing, I'd like to address one more topic. And this is related man or woman versus machine. In fact, it's a fear-ridden debate which is sometimes misguiding or misleading. Of course, more and more AI applications are coming into our life, and having, let's say, certain anxieties and fears are normal, which also needs to be addressed. I am involved in several discussions in different parties saying, well, AI is taking jobs or killing jobs. That's not the case. That's not the case. As we have seen with AI applications, especially with industrial AI, we can run things better, identify things better, and have a better life. And here is important that we, human, man, woman, are developing the AI systems or industrial AI systems. Therefore, our saying is we have to continue developing things to make our lives better. And in this context, we are not talking about man or human versus machine. We are talking about man and machine. So that is, I think, important that we keep in mind. With AI, in fact, we are creating new kind of jobs, new kind of applications, and certain, let's say, jobs might disappear, but new ones will appear and also make our lives better. So with this in mind, I like to close saying again, we are here together with our customers to co-create a digital future with Siemens industrial applications. Thank you very much. Thank you.
Thank you very much, Mr. Elver, for joining us this morning. Ladies and gentlemen, we will now kick off the next keynote with a short video about Micron.
Connections. The world is built upon them. When we connect, we learn, we share, we grow. Life moves fast. In order to keep up with the challenges of today, intelligence is key. Intelligence that connects data algorithms with our day-to-day rhythms. Intelligence that delivers precise treatment, unlocking hidden cures. Intelligence that informs teams to make smarter decisions, faster. And intelligence that predicts and protects us from harm. Micron is essential to the world's most inspiring innovations, accelerating the technology that is leading us into the future. The world is entering a new intelligence shift. The connection between compute and memory has never been more essential in bringing intelligence to light. When we connect, there's nothing we can't do. Micron, intelligence accelerated.
And our next speaker will be Thomas T. Eby. Mr. Eby is Senior Vice President and General Manager of the Compute and Networking Business Unit at Micron Technology. He is responsible for managing Micron's memory portfolio that supports the compute and networking marketplace. So ladies and gentlemen, let us put our hands together and give a very warm welcome to Thomas Eby.
Good morning. I'd like to thank you for your time. Thanks to Tetra for the opportunity to share some of my thoughts on behalf of Micron. And I would also repeat a comment from one of the earlier speakers that it's good to get that huge picture of my face off of the screen. You heard from the first couple of speakers, some of our colleagues from ARM and from NVIDIA, talking about some of the opportunities and challenges in terms of unleashing this massive amount of data that when AI is applied can provide just incredible value. And they're, of course, doing it from more of a processing element perspective, an increasingly heterogeneous set of processing elements and the associated software frameworks. What I'm going to do over not quite the next half hour is really look at the same problems, but rather than doing that from a processing element perspective, I'm going to do it from the perspective of memory and what Micron is doing in evolving our memory and storage subsystems to support this incredible AI evolution and unleashing of the value of the massive amount of data being created. So, Mark from NVIDIA, I believe he talked about, data being the source code. I guess if you process that source code properly, it becomes much more valuable. And we like to think of the term that, data is the new global currency. There is a staggering amount of information being produced on an ongoing basis. Per IBM, about 90% of it has been produced in the last 2 years. About 2.5 exabytes worth of data are produced every day. Since I got up on stage, about 40 million texts have been sent. But without the ability to manage that data, to store it, to access it, to process it with sufficient density and in a time frame of relevance, it's just that, it's data, right? It can't unlock the insight and the competitive advantage. It can't become the global currency. So, we spent quite a bit of time at Micron studying, hey, what are those changes that are required from an architectural innovation perspective in order to, unlock that value and turn data into the global currency. And to help us, we commissioned a third-party survey. They went out and talked to a couple hundred leading architects and IT experts that are designing artificial intelligence systems, to share with us, what are some of the most critical challenges that they face. And while certainly the compute elements, the degrees to which they are becoming much more heterogeneous, certainly the software environment needed to write code, and certainly security are all important issues. Far and away, the most important issues were related to the memory and storage subsystems needed to support AI. Put another way, how do you feed the beast, right? So a few of the specific findings. Certainly a great focus on taking the compute and memory systems that are providing AI and getting them closer and closer to the sources of the data. And this is, of course, what's driving the explosion in edge compute, certainly with a tendency towards inference. Another area of greater proximity is between the compute and the memory itself. Increasingly, the performance of systems is being influenced as much in terms of both performance and power consumption by the movement of data as by how that data is processed. And that means ever more intimate association of compute with memory and potentially over time finite elements of compute actually in the memory themselves. As Renee talked about, there's also a significant greater degree of heterogeneity, in the architectures in general, certainly in the data center. That's something I'll talk about a little bit later in my talk. And finally, specifically in the application of training, memory bandwidth is the key differentiator in terms of the performance of those training systems. So, in terms of looking at some of the changes in architecture and how they apply a little bit more specifically to AI problems, we're going to look through a handful of applications, not surprisingly, a number of which have been discussed already by some of the earlier speakers. And we'll talk about them in terms of what is unique in terms of their needs for memory bandwidth or for memory density to be able to contain a sufficient amount of data being analyzed. Or for much larger workloads, what are the requirements in terms of storage density and storage throughput? As you can see, we're going to look at this through the lens of some science and medical applications, look at it through the lens of the new data center on wheels, which is automotive, and then finally, an area where, to use a phrase, we are eating our own dog food, which is applying machine learning in an IoT environment in the fabs that we use to build the products that enable AI. So we're going to start, with the field of medicine, and in particular, cancer research, and a fairly focused challenge in terms of how you do the detection, the validation of the effectiveness of treatment, and ideally going forward, ever more personalized treatment of cancer. As Mark from NVIDIA talked about earlier, the traditional ways that this is being done, he used an example of bone density, is a very manual and laborious process. Looking at images and comparing to known sources of cancer, again, very very tedious, and it doesn't scale, and it certainly doesn't lend itself to the type of customization that we ultimately want to get to. In this case, certainly there is an issue of the necessary memory bandwidth to do the inference on these very large images. Typically, these are 8K and 10K image resolution photos. But the other one is memory density. There's a substantial problem that people have faced in terms of very high density or high resolution images. They need to chop the images up into multiple partitions in order to get them to fit into the processing elements that do the inference. And we're working on a solution that actually has a ½ terabyte of high performance memory, so you can take these very high density images all at once into the system and not have to deal with those edge effects. So more effective, identification, more effective optimization, and again, a path towards customized treatment for a variety of cancers. We're going to switch now from what is a relatively bounded problem. The search for cancer generally, we know what we're looking for, to one that is much less bound. CERN is the European Center for Nuclear Research. It is at the cutting edge of physics and searching for new particles and looking to unlock increasing details around the mystery of the formation of the universe 14 billion years ago. To borrow a phrase that Mr. Wang used in his opening, CERN is actually going through a digital Big Bang in order to help understand the original Big Bang. That happens to be the home of the largest super collider on Earth that produces just staggering amounts of data. I believe it's about 5 petabytes of data a day. And it produces so much data that they can't store it all. And so they have to decide what information or what data has high enough potential that it might be worth something. Again, they don't know exactly what they're looking for, but they have some idea of what might be useful. And they have to make that decision of what to save and what to drop on the floor in a little under 10 microseconds. So in this case, we're working, very high bandwidth memory solution, the IP needed to transfer that data very effectively, and then going forward, also the high performance and high density storage systems to help them solve this problem. So we'll switch now from the data centers at CERN to the data centers on wheels, which are increasingly our cars. Mark and Renee, I guess Renee talked primarily about autonomous driving. I'll certainly get to that. But I think simply the in-vehicle experience is also a significant driver of content and bandwidth. When you look at the decision factors that people use in deciding which cars to buy, increasingly it is about that in-vehicle experience, about the entertainment, about the degree to which the human-machine interface can tailor the environment in the car specifically to the driver. And when you look out at cars that will become self-driving, there are likely to be half a dozen to a dozen very high-resolution displays. And the bandwidth to drive just the in-vehicle experience portion of the car is going to be between 150 and 300 gigabytes per second of bandwidth, and use about 10 times the amount of memory that a very high-end car uses today. Certainly, autonomous driving is another staggeringly bandwidth-intensive application. There is an influx of real-time data from cameras, from LiDAR, from radar, car-to-car communication, infrastructure-to-car communications, and others, that by the time in the middle of the next decade we do get to full autonomous driving, is going to require between half a terabyte and a terabyte per second of memory bandwidth. There was a comment one of the earlier speakers made about how it's been an incredible evolution here at Computex from what was a very significantly gaming-oriented show 15 years ago to what we're talking about today in the areas of AI and 5G. There's an interesting parallel there. One of the technologies that is increasingly being applied to solve both the in-vehicle experience as well as the autonomous driving problem is graphics memory. Again, originally invented for memory, we've taken that, produced automotive-grade versions of it, and it's incredibly valuable in these applications, and it is strengthening Micron's position as the leading provider of automotive memory and storage. So one last example before I leave the automotive case study. Renee had talked from ARM, had talked a bit about a number of analogies between the problems that they are seeing in autonomous cars with what they've seen historically with aircraft. He was talking about it from a software complexity perspective, from a security perspective, but there's another, which is the increasing need for black boxes in cars. There is a desire as we move forward towards autonomous driving that there be the ability to capture a couple handfuls of events, about 30 seconds each, pretty high bandwidth, need to write about a gigabyte per second. And it's going to be a relatively small drive, but rewritten over time. And so the aggregate write capacity of this drive, the endurance need, is about 150 petabytes over its lifetime. So an incredibly challenging storage application, both from a performance and from an endurance perspective. So the last example that I'll talk about is, I mentioned, we're eating our own AI dog food, as it were, and we're using AI techniques to enhance the quality and capability of the products that we build that in turn enable AI. Our fabs are becoming very complex, IoT deployments. We have acoustic sensors in much of the equipment that is listening for acoustic anomalies for both predictive maintenance and to reduce downtime when they do occur. We are looking at the staggering reams of electrical data, known as probe data for those of you in the industry, that comes off the wafer when it first comes out of fab, again, to think about how we can provide feedback back into the wafer fab processing environment, as well as feed forward into the assembly process to improve yields and to improve quality. And then finally, another imaging example, this one in manufacturing, where we do ongoing visual inspection, again, looking for defects in the product. Mark from NVIDIA would be glad to hear we use DGX machines for training. Currently, we are deploying the inference actually on a data center based platform, although we will be moving to lighter weight edge inference solutions, probably the Raspberry Pi or perhaps Jetson, as we move forward. And the results of all this are quite impressive. We are seeing about a 25% improvement in the time to mature manufacturing yields on our leading edge nodes. We're seeing about a 10% improvement in output on the same equipment set out of our fabs. and a little bit more than a 1/3 reduction in quality events from coming off of our manufacturing line. So overall, a very virtuous cycle in terms of our improving our products to help improve the AI systems that help make them. So, when we've talked, most of what I've talked about have been more edge-oriented, a little bit of training certainly quite a bit of training in the fab environment, but the others are more inference edge environments. And, you might think, okay, so in terms of the balance of growth between what's happening at the edge and what's happening at the server, which one is going to dominate? And the answer to that is really yes, right? It's going to be a distributed server architecture with substantial growth from the edge to the core, and a distributed server deployment not unlike that which is going to be used for 5G. But that doesn't mean that some of the architectural changes, the increased heterogeneity that we see in edge inference devices isn't also coming to the data center. Certainly, the data center architectures will continue to play the core wars, and so we'll need to keep feeding the traditional CPUs with faster and denser DDR4 and going forward DDR5. But there'll be a much more significant growth in the GPUs, the FPGAs, the neural net processors, and the ASICs, very finely tuned to the specific applications that they're trying to address. And of course, each of those heterogeneous elements affords an opportunity to tailor the memory that we're using to feed that, and it also drives overall memory growth. An AI-optimized server in the data center is typically anywhere from 5 to 10 times the memory and storage content of a more traditional server architecture. So, what does Micron bring to this? I've talked about a couple examples so far, but to talk in a little bit broader perspective, we are the only player that brings the full breadth of DRAM, 3D XPoint, and NAND technologies to this evolving, ever more heterogeneous architecture that is driving AI. Certainly from a DRAM perspective, high volume, DDR4 and 5 in the data center, LP and mobile, but also the higher bandwidth solutions, the graphics memory that I've already talked about, the HBM that's in development, which is driving the very highest end, training applications. We, a bit over a year ago, took one of the first steps towards persistent memory with our non-volatile DIMM solution, which combines DRAM with the ability to back up that to NAND in the case of power loss. It's important as future technologies like 3D XPoint are persistent, and so we can both learn how to take advantage of the opportunities that it affords. For example, certain database applications can be substantially sped up, storing the key metadata in NVDIMM as opposed to on SSDs. But it also brings issues that we need to address, and again, that a couple of the earlier speakers talked about, and in particular, security. DRAM resident data is generally unencrypted. As we move towards persistent memory, without encryption, that becomes an incredibly attractive attack surface, and so one that we're looking at in terms of how we always make sure that we don't have persistent, unencrypted memory in the clear. Certainly, continuing on to the right, both the high-performance solutions that can be enabled, by TLC NAND, and certainly on the leading edge of what we see being the most cost-effective NAND going forward, QLC, which at least early on appears to have some very attractive opportunities in streaming. Now, this, of course, is very much a data center view. We certainly supply the LP and the managed NAND for mobile phones. Rene had talked about the fact that the example he used of essentially, synthesizing a real-time video in front of Taiwan 101 wasn't reality yet because they didn't have the throughput. And I'm certain that part of that is the throughput with regard to the SoC, but also an equal important part of that is the throughput, from both the memory and the storage subsystem. And so those are the sorts of things that that we will be solving going forward. In addition to a broad product portfolio, we also bring our global footprint to helping to address these AI-driven architectural challenges that we've talked about. Certainly we do that so that we can avail ourselves of the best talent around the globe. We do that because we want to make sure that we are close to and can collaborate with customers, ecosystem partners, universities, and other groups that can benefit from that collaboration. By the way, one new aspect of collaboration that we announced last fall is very specific to AI. We have launched a $100 million AI fund, investing in innovative companies developing leading-edge solutions to AI, and with 20% of that fund dedicated for women-run organizations. So if there are bright ideas out there in the audience, we would love to hear about them and work with you on that. And then finally, I can't leave this slide since we are here in Taiwan and not point out that our global footprint also includes being the largest foreign employer and the largest foreign investor in Taiwan, which is an incredibly important DRAM center of excellence for Micron. Before I wrap up, I'm going to do one last tie back to the discussions about the earlier roots of Computex being very much focused on gaming. We've announced a couple of times, and I'm told this actually may be 24 hours out of date, but we'll catch up again quickly. What is the fastest overclocked liquid nitrogen cooled DRAM on the planet? So all you gamers out there, please be sure to come to our booth and take a look so you can see what the highest performance gaming memory in the industry looks like. So hopefully you've gotten a better feel over the last 25 minutes or so of how Micron's memory and storage solutions are enabling the transformation of IT architectures so that we can unlock that value of the incredible explosion of data and truly turn that into a global currency. Our vision is to take full advantage of that opportunity and transform how the world uses information to enrich life. We invite all of you, be that customers, ecosystems, partners, or otherwise, to work with us or continue working with us so that we can continue to achieve that vision. And with that, I would again like to say thank you for the opportunity to speak with you today. Thank you for your time, and enjoy the show.
And thank you, Mr. Eby, for joining us this morning. And the next speaker will be Sean Dean. Sean is the chief scientist of AIoT, Alibaba Cloud Intelligence. He's an expert on sensation and cognition and has been devoted to IoT and AI for over 20 years. Prior to Alibaba, he has worked in Silicon Valley for 15 years. Today, he will talk about AI for manufacturers' digital transformation. Without further ado, please welcome Sean Dean. Artificial Intelligence。我们今天早上的议程到这边圆满落幕了。我们现在进行的是午餐休息的时间。我们再次提醒大家，可以来扫描证件背面的 QR code 来填写线上问卷，完成截图可以到我们的报道台兑换数位时代一本。同时也提醒您，我们这一个场地中午会进行清场，我们请在座的贵宾不要忘记，要务必带走您所有的随身的所有的物件跟用品。And the forum on AIoT will begin at 2 o'clock in the afternoon, and the doors will open at 1:30. 提醒大家，下午的 AIoT 论坛将于2点开始，1点半开放入场。再次感谢您的莅临。